Good evening, and welcome to Story of the Cosmos. Tonight, we go looking for the largest black hole humanity has ever measured, and find that even our biggest numbers cannot quite hold it. A raindrop of light left its source before your grandparents' grandparents were born, and it is only now touching a mirror on Earth. Out past the reach of any lamp you've ever seen, past the last familiar shapes of nearby galaxies, there is a darkness that is not empty. Somewhere in it sits something so large that the word large barely survives contact with it. It has no edges you could walk toward. It has no face. It does not pulse or announce itself. It simply is, has been, for longer than there were eyes anywhere to notice. Light takes time to travel. You know this. But knowing it and feeling it are different things. And this is a story that asks you to feel it, slowly, the way you'd feel cold water rising past your ankles and then your knees. Because the light we will speak of tonight left its source before the sun existed, before the earth had cooled, before there was a here for it to be travelling toward at all. It has simply been crossing the dark, patiently, for billions of years, arriving now, tonight, for no reason except that this is when it happened to get here. Whatever sits at the far end of that light does not know you are here. It does not know Earth is here. It will never know. And there is something almost peaceful in that. A vastness so complete it cannot be bothered with you, or with anything at all. It has a name and a number and a story of how we found it. That comes next. For now, only the dark and the light still falling through it. A single point of light on a photographic plate, so faint, so ordinary, that no one thought to look twice. That is how it began. Not with a warning, not with a name. In 1957, at the Tonantzintla Observatory in Puebla, Mexico, two astronomers, Braulio Iriarte and Enrique Chavira, were pointing a small telescope away from the crowded plain of the Milky Way, hunting for faint blue stars. It was careful, unglamorous work. Thousands of dim points of light, each one photographed, measured, filed. Most of them were exactly what they appeared to be, small, cooling stars nearing the ends of unremarkable lives. One of them was not. On the plate, it showed as decidedly violet, the kind of colour that made it worth a second glance, a candidate for a white dwarf, perhaps, or some other spent, forgotten star. It was given a magnitude of 16.2, faint enough to vanish into the noise of the sky. It was given coordinates, and it was given a number, 618, one more line in a long, patient catalogue of things that looked small. They called it Tonantzintla 618, Ton 618 for short, a name with no menace in it at all. There is something worth sitting with here, quietly, before moving on. The largest object of its kind ever measured did not announce itself. It did not blaze or roar or demand attention. It sat in an archive, indistinguishable from stars a billion times smaller, filed under the same routine label as its plain, dying neighbours. The universe does not sort its extremes by how they look on a first pass. Sometimes the most violent thing in it wears the most forgettable disguise. And there was no way yet to know otherwise. The very idea of what this object actually was, a quasar, a beacon powered by matter falling into something unthinkably massive, would not exist for scientists until 1963. So for years, Ton 618 waited, not doing anything, not changing, simply sitting in a drawer in Mexico, a faint violet dot among faint blue dots, while the concept that could have explained it had not yet been born. Somewhere, 11 billion years away, the true scale of the thing was already unfolding, had already been unfolding for longer than most stars live. But here, in a filing cabinet of glass plates, it was just entry number 618. A curiosity. A maybe. A footnote. It would take another survey and another set of eyes to notice that this particular point of light did not behave like a star at all, that something about it did not fit. But not yet. For now, it is still just a faint violet dot sitting quietly in a catalogue, keeping it secret a little longer. For years, no one knew what they had found. Something that fed on cold gas and light and time. A dish in Bologna heard it, without a name for what it was hearing. In 1970, a radio survey there swept quietly across the sky and picked up something coming from that same faint point in the old Mexican catalogue. Stars do not usually speak in radio waves. Whatever this was, it was not behaving. So a spectrum was taken, properly, carefully, at the McDonald Observatory in Texas, by an astronomer named Marie-Helene Ulrich. She split the object's light apart into its component colors, the way all such objects are finally understood, and found lines in it that no ordinary star produces. Broad, smeared, stretched far past where they should sit. That stretching had a name, redshift. And when Ulrich measured it, the number that came back was almost too large to make sense of at first. A redshift of 2 and 2/10 beyond that. It meant the point of violet light was not a nearby star at all. It meant the light arriving in that telescope that night had left its source 10,800,000,000 years ago, and had been falling toward Earth in a straight and patient line for the entire span since. Sit with that for a moment. 10.8 billion years is not a distance you can picture the way you picture a mile, or a mountain, or even the moon. It is closer to a debt the universe has been quietly paying down, one photon at a time, since before almost everything you have ever known existed. And there is a colder detail hiding inside that number. The universe was not standing still while that light traveled. It was expanding the entire time, stretching the space the light had to cross, faster in some eras than others, so that the point where TON 618 sits today is no longer 10.8 billion light-years away at all. It is closer to 18 billion. The object kept receding, even as its own ancient light pressed forward through the growing dark to reach a planet that, when the journey began, did not yet have this shape. What arrived in that Texas spectrograph, then, was never a picture of TON 618 as it is. It was a fossil. A signal frozen at the moment it departed, carried across a gulf that kept widening behind it the entire way, indifferent to whether anything on the receiving end would ever be built to notice. Ulrich could not have known, sitting with that data, just how large the thing at the other end of that signal would turn out to be. Only that it was far. Far enough that anything producing light this bright, at a distance this immense, could not possibly be a star. The catalogue entry did not change. The name stayed the same, a small, unassuming string of numbers filed under Tonantzintler, 618. But what it pointed to had quietly become something else entirely. Not a star mistaken for a curiosity, but a beacon from near the edge of observable time, its true nature still, for now, unweighed. The light was ancient long before it ever arrived. TON 618 kept its secret a little longer. Because knowing that something is far does not tell you how heavy it is, and heavy, here, is the only question that matters. In 2004, a team led by Ohad Shemer studied the shape of one particular signature in TON 618's spectrum, the hydrogen line called H-beta, and used the speed of the gas swirling near the black hole, some 10,000 kilometers each second, to work backward toward a mass. The number they arrived at was staggering: 66 billion suns. Not 66 billion stars scattered across a galaxy, 66 billion suns folded into one point of gravity. A figure large enough that it stopped sounding like astronomy and started sounding like a rumor. For 15 years, that was the number the universe was asked to live with. Then, in 2019, a second team, Schweger and colleagues, returned to the same object with a different tool. Not the hydrogen line this time, but a line from ionized carbon, carbon-4, tracing gas moving far more slowly. Only 2,700 kilometers a second, not 10,000. Slower gas implies a gentler pull. A gentler pull implies less mass. Their answer? 40 billion suns, give or take. Two teams, two careful readings of light from the same impossible object. Two answers that disagree by 25 billion suns, a gap larger than the mass of some entire galaxies sitting in the space between them. This is not a story about scientists getting it wrong. It is a story about what it actually means to weigh something that no instrument will ever touch, that no ruler will ever span. A number inferred from the flicker of a single spectral line, arriving after 10 billion years of travel, and then translated, cautiously, into mass. Every method carries its own assumptions. Every spectral line moves for its own reasons. And so, even now, Ton 618 does not have a mass. It has estimates, plural. What is not in dispute either way is the scale of the thing being disagreed about. Take every star in the Milky Way, every burning point of light in our galaxy, and add them all together. Roughly 64 billion suns worth of mass. The higher estimate for Ton 618 outweighs all of it. One dark object, heavier than the combined stars of the galaxy that holds us. And even the cautious figure, 40 billion suns, rivals that same total. A single point of collapsed matter weighed against everything that shines around us, and barely coming up short. 15,000 times heavier than the black hole at the center of our own galaxy, and that is using the larger estimate. Even the cautious number leaves it 9,000 times heavier. And this is, perhaps, the quieter lesson inside the loud one. The universe does not hand its numbers over freely. Even here, at the far edge of what can be measured, astronomers are not reading a label. They are reading light, old, stretched, faint light, and reasoning carefully backward through it, toward a truth that may never fully resolve. Somewhere between 40 billion and 66 billion suns, there is a real number. It does not know that we are still arguing about it. A circle wide enough to hold the entire orbit of Neptune, drawn again and again, 80 times over, before its edge is finally reached. That is the boundary. Not the black hole itself. No one has seen that, no one ever will. But the horizon around it, the last line where light still escapes, before it turns back and gives up any hope of return. No telescope on Earth, not even the ones built to photograph event horizons directly, can resolve anything so small and so far away. Everything known about this boundary comes from arithmetic, not from sight. To draw it, astronomers first had to trust one of those two impossible numbers from before: 66 billion suns, or the smaller, more recent 40.7 billion. Using the larger figure, the mathematics is coldly simple. Mass determines size. A black hole's event horizon, its Schwarzschild radius, grows in direct proportion to how much matter is folded into the point beneath it. Multiply the mass of Sagittarius A star, our own galaxy's quiet resident black hole, by more than 15,000, and this is the boundary you arrive at. 1,300 astronomical units, the radius, 2,600 across. In kilometers, that is nearly 400 billion, a distance the mind was never built to hold, so it reaches for something familiar instead. The solar system, the one you already know, the sun, the rocky worlds, the gas giants, out to Neptune, tracing its long, cold circuit through the dark, once every 165 years. Take that entire orbit, every world inside it, every year Neptune has ever slowly completed, and let it shrink to a single small ring. Then, place that ring inside the horizon of ton 618, and do it again, and again. 80 times the ring repeating before you finally reach the edge. Even the more conservative estimate does not rescue the imagination. 40.7 billion suns, the smaller number, still draws a boundary 800 astronomical units wide, 40 times the distance from the Sun to Pluto on its own. There is no comfortable version of this. There is only less unimaginable and still unimaginable. And nothing marks this boundary. No wall, no light, no shimmer in the dark to warn a traveller where the solar system's echo would end and the black hole would begin. Cross it, and you would not feel a door close behind you. You would simply be on the other side of something with no way back, and for a long while afterward, nothing about your body or your senses would tell you anything had changed at all. That is the quiet cruelty of a scale this large. A boundary drawn not in violence, but in distance. A circle so vast it swallows the memory of our entire solar system 80 times over, and asks for nothing in return but silence. The mind tries to hold it, and fails, and that failure is not a flaw in the thinking. It is simply what happens when a number this large meets a brain built for smaller things. Somewhere out there, that edge is still waiting, wide, dark, and indifferent to whether anyone could ever picture it. Ton 618 is not merely large. It is bright enough to be seen from Earth by a hobbyist's telescope, across 10 billion years of empty space, which is a strange kind of violence when you think about it. At its center, gas does not fall in quietly. It spirals faster and faster, reaching speeds of 7,000 kilometers a second before it crosses the edge, friction building on friction, until the infalling matter is hot enough to outshine almost anything else the universe has made. The number astronomers arrive at is 140 trillion times the brightness of the Sun. Not compared to a star, compared to 140 trillion stars, all at once, from a single point of light. And still, this is not an explosion. It has no beginning and no end that we have witnessed, only a steady, furnace-like burning that has likely continued, unwatched, for longer than human history has existed to notice it. Here is the quiet part. Light this bright does not need to be close to reach you. Ton 618 sits so far away that its glow left home when the universe was a fifth of its current age. And yet, enough of that light survives the crossing, undimmed enough, that it registers as a faint point on a dark sky photograph. A lighthouse does not dim because the sea between you and it grows wider. It only takes longer for the light to arrive. Astronomers give this brightness a number 2, an absolute magnitude of nearly 31, one of the highest ever assigned to a single object. But even that number can mislead, because absolute magnitude describes what something would look like nearby, and nothing about Ton 618 has ever been nearby. What crosses 10 billion years of expanding space and still registers on Earth is not a full accounting of its power. It is only the fraction our instruments happen to catch. Consider what that means. The Sun, this close, warms a planet. Ton 618, this far, still manages to leave a mark on a photographic plate on the other side of the universe, filed once as a faint violet star, decades before anyone understood what they had actually found. It does not blaze for us. It does not know we are counting its photons or measuring its magnitude or wondering, quietly, how something can burn this steadily for this long without consuming itself. It simply spirals and heats and shines, indifferent to the 11 billion years its light spends traveling toward a small blue planet that was not there when the journey began. A furnace with no audience, until now. Around it hangs a fog, 300,000 light-years wide, and for 60 years, no one knew it was there. In 2021, astronomers turned the Atacama Large Millimeter Array toward TON 618, and its light did something unexpected. It did not stop at the edges of the galaxy holding it. It kept going. Wrapped around the quasar and its host is an immense shroud of hydrogen gas, glowing not with its own warmth, but with a light borrowed from the thing at its center. Astronomers call structures like this Lyman alpha nebulae, vast clouds of hydrogen lit up when high-energy radiation strikes their atoms and forces them to release that violet-tinged glow. This one stretches at least 330,000 light-years across. That is more than twice the width of the entire Milky Way, a halo of gas larger than our own galaxy, built around a single point of light. Within it, the data show two distinct layers. Close to the core, a churning outflow of molecular gas, pushed outward by the black hole's own furnace. Farther out, a colder, quieter reservoir, gas drifting through the space between galaxies, patient, undisturbed, stretching for hundreds of thousands of light-years in every direction. Each of these two components carries roughly 50 billion times the mass of the Sun, in hydrogen alone. And both are aligned with something else entirely, the jet. TON 618 is one of the rarer quasars that streams matter outward at nearly the speed of light, and the nebula's shape follows that jet's path, as if something unseen is combing the gas into order. None of this hydrogen makes its own light. It only answers. The radiation pouring outward from near the event horizon reaches each atom in that distant cloud and calls a glow out of it, the way fog around a lantern does not burn, only receives. Picture it slowly, if you can. A black hole 11 billion years away, wrapped in a haze larger than a galaxy, every particle of it lit from within by a light it did not make and cannot escape. It is, in its way, the quietest violence imaginable. Not an explosion, not a devouring, just a steady radiance moving outward for hundreds of thousands of years across gas that will likely never fall in, never be touched, only illuminated. A monument built of light instead of matter, standing around something that does not know it is beautiful. Fog around a lantern, and nothing more. A body falling toward an ordinary black hole comes apart long before it arrives, pulled thread-thin, atom from atom, well outside the edge itself. That is the small, sudden violence people imagine when they hear the word. It is real for objects the mass of a dying star. Their gravity changes so sharply over so short a distance that a falling body is stretched apart by the difference between what pulls at its head and what pulls at its feet. A force strong enough at the horizon of a stellar black hole to reach nearly 20 billion meters per second squared. Spaghettification, the physicists call it, almost gently, as if giving it a soft name could make it easier to hear. TON 618 does not work that way. Its horizon is so unimaginably large, light hours across, not kilometers, that gravity barely changes from one side of a falling body to the other. The stretching force at its edge has been calculated at less than 2 millionths of a meter per second squared. A person crossing it would feel nothing. No pull, no warning, no instant where the body understood what had happened to it. Only the ordinary weight of falling, the way a stone falls, the way rain falls, continuing on exactly as it had a moment before. There would be a last image, a last thought even, and no signal anywhere in that moment that it was already the last. This is the quieter danger of something this vast. Not that it destroys you, but that it erases the boundary between safety and catastrophe so completely that you cross from one into the other without any seam to mark the difference. The violence does not disappear. It only moves, deeper, invisible, waiting much further in a place no traveller crossing the horizon could ever report back from. By the time it arrives, whatever crossed is already gone in every way that matters, already unreachable, already past the last point where too late could have meant anything. Scale, here, does not make a thing gentler. It only makes the gentleness a kind of disguise, a horizon so calm it could be mistaken for empty space, wrapped around a fate no less final than the smallest black holes, only slower to arrive and impossible to feel coming. Nothing about TON 618 announces itself. Not at first glance in 1957, not at the edge of its own horizon now. You would not know. That is the whole of it, and so it rests. Rewind far enough, and the dark gets younger too. Roughly 10,800,000,000 years ago, when this light first left its source, the universe itself was not yet a fifth of the age it is now. Barely 3 billion years old, still gathering itself out of the earliest dust and hydrogen. And already, TON 618 was there. Already vast. Already burning at the outer edge of what a single point in space is allowed to become. This is where the ordinary explanation starts to strain. The black holes astronomers understand best grow slowly. A dying star collapses, a remnant forms, and over billions of patient years it feeds, merges, feeds again, until it has added enough mass to matter. That path takes time. TON 618 did not have time. Only a few 100 million years stood between the universe's first light and a black hole tens of billions of times heavier than the Sun. So there is another possibility, quieter and stranger than stellar collapse. Somewhere in that early dark, a cloud of primordial gas, vast, cold, ordinary in every way except its size, may have collapsed directly into a black hole, skipping the star entirely. No fusion, no fanfare, just gravity, folding 100,000 or 1,000,000 suns worth of gas straight into a seed with no beginning as anything else. A black hole born as a black hole, already large, already hungry, with billions of years still ahead of it to grow larger. If that is what happened here, TON 618 did not earn its size the slow way. It was given a head start before the universe had properly begun. And there may be a limit to how far even that head start can carry something. Beyond a certain mass, the theory goes, a feeding black hole starts to choke on its own light, radiation pressure pushing back against the very gas trying to fall in, until growth stalls near some upper boundary few objects ever approach. Estimates place that ceiling somewhere around 50 billion suns, perhaps a few 100 billion in the rarest, most extreme cases. TON 618's mass, however it is finally settled, sits close enough to that number to raise a quiet question. Not simply the largest one found so far, perhaps close to the largest one physics allows. A boundary at the edge of the universe's youth, a boundary at the edge of mass itself. It may be standing at both. Final narration. No telescope built, and none yet planned, will ever resolve its event horizon into an image. Everything known about TUN 618 has arrived second-hand: a spectrum, a redshift, a flicker of radio noise, and now a shroud of hydrogen glowing faintly around it, 300,000 light-years wide. And still, astronomers argue over its crown. Phoenix A star, sitting in a distant cluster. S50014 plus 81, another quasar burning at nearly the same extreme. A black hole in the galaxy Able 1201, weighed not by its own light, but by the way it bent someone else's, from a galaxy billions of light-years closer than TUN 618 will ever be. Each one measured by a different method, each carrying its own uncertainty. The ranking shifts a little every time a new paper appears, and the title of largest black hole ever found is not a settled fact. It is a question, quietly re-asked every few years by people who may never agree. There is something else worth sitting with before the lights go down. The light now arriving in our instruments left TUN 618 when the universe was not yet a quarter of its current age. There was no Earth yet to wait for it, no ocean, no sky, no one to look up and wonder. It has been crossing the dark for nearly 11 billion years, indifferent to whether anything would ever be here to receive it. It is immense beyond comparison. It is farther away than the mind can really hold, and that distance is exactly what turns something this vast into a story instead of a threat, something to be measured and argued over, and slowly understood from very far away. Somewhere out there tonight, something enormous and still unmeasured keeps quietly burning. None of it can ever reach you here. This has been a story of the cosmos. Out there, the stories go on, slowly, quietly, as they always have. Let this one drift on without you until the next journey.